Earlier in this course, you learned that classes are building blocks of our applications. These classes combine related variables or fields and functions together. So here's an example. In this picture, we have a class called person with 4 fields: name, age, height, and weight. And it also has 4 methods or 4 functions: walk, talk, eat, and sleep. This class is a type or a blueprint from which we create objects. So an object is an instance of a class. In this example, we can create 3 instances of this person class, like John, Mary, and Scott. So more accurately, when you run your application, it's these objects that are talking to each other and collaborating to provide some functionality. But the word class and objects are often used interchangeably. Okay, now let's see how we can create a class in C#. So to create a class, we start with an access modifier, and then the class keyword, and an identifier. An access modifier determines who can access this class. For now, don't worry about it because that's something I have covered in my C# intermediate course, which is the second part of this course. Just remember, whenever you want to create a class, use the public keyword to make that class accessible anywhere in your application. Inside the code block for the class, we can have variables, which we call fields. Also note that when we declare a variable, we need to specify an access modifier. Again, for all examples in this course, we're going to stick to public, and in the next course, we'll take a look at other access modifiers. Note that in C#, anywhere you have a statement, like a variable declaration here, you need to terminate that statement with a semicolon. But you don't have to do that when you have a code block. Your classes can also contain methods. So here is an example. In this example, void is the return type for the introduce method, which means this method does not return any values. And also note that this method does not take any parameters, as indicated by empty parentheses. So it simply outputs the name of the person on the console. Here is another example. In this example, we have a calculator class with 1 method, which takes 2 parameters of type integer and returns an integer. Now that we have a class, let's see how we can create an object. So earlier, you learned that to declare a variable, you start with a type and then an identifier. Creating objects or instances of classes is pretty similar. We start with a type and an identifier, but there is one more step. We need to allocate memory for that object. And that's when we use the new operator. So in C#, classes are treated differently than primitive types. So you need to explicitly allocate memory for them. But the good thing is, unlike languages like Objective-C or C++, you do not have to worry about deallocating that memory. CLR, or Common Language Runtime, will take care of that for you. It has a process called garbage collection, which automatically removes all objects that are not used. So to allocate memory to an object, use the new operator, and then repeat the type of the class and parentheses. You can make this code a bit shorter by using the var keyword that you learned earlier. And now that we have a person object, we can access its members like name field or the introduce method using the dot notation. So in this example, I set the name of this person and then call the introduce method. Now let's see what is that static modifier that you saw in our first C# program. So here is the calculator class that you saw earlier. We can modify this add method with the static keyword like this. And as a result, we can access that method directly via the calculator class itself. We do not have to create an object to access a static member. In fact, we cannot access static members from objects. So what is this all about? Why do we need this? Well, let me show you what's happening behind the scene, and then you will have a better understanding of this. So without the static modifier, when you create 3 objects of this calculator class, each object in the memory will have the add method. But when you apply the static modifier, that add method will be only in one place in memory, and that is the calculator class itself. So it's not going to be repeated 3 times in memory. But why do we need this? We use the static modifier when we want to represent a concept that only a single instance of that should exist in memory. Here's an example. Remember the program class in our first C# program? So there we had a main method, and main was modified with the static keyword, which means there is only one instance of the main method in memory. There is only one entry point in each C# application. Current datetime is another example. You don't want to have multiple datetime objects in memory, each representing a current datetime. You want only one place in memory where you can look at the current datetime. So all I want you to know for now is that when you modify any members of a class, whether it's a field or a method, with a static modifier, that member will be accessible from the class itself, not an object. Well, that's enough theory for now. Let's flip over to Visual Studio and do some coding.